Hello, welcome to another briefing. So, in this briefing, I'm going to start out, as I usually do, with looking at the satellite imagery, and we have an overlay of the current pressure heights, basically air pressure in between the surface and 18,000 feet, which is the half point up the troposphere where most of our weather occurs. And what we're observing is a trough. You see this troughing pattern where you have dropping heights, um, and you have, if you were to pick out more or less where the jet stream is, it's roughly over here. It's doing something like this. This is probably not completely accurate, but actually I'm gonna do a better job. So the strongest winds are around roughly over here. This is roughly what the jet stream is doing. It's probably really a little further to the north than this, but basically we're seeing a lot of lift. We're seeing there's this big low to the north over here, and it's causing a lot of lift in the atmosphere. So any kind of moisture, it's not a lot of moisture that we have, but the moisture that is available is all getting pushed up into parts of the Sierra Nevada. It looks like south-facing areas are going to favor more precipitation, rain, and snow at high elevations. South slopes will be more favored due to that south wind component. Unfortunately, looks like just not enough moisture lining up with these dynamics to bring significant rain to places like the Bay Area or the valleys, but it's still nice to see a little system moving through. This definitely brings a cool down, and if I put this animation going from yesterday into today, you can see yesterday afternoon, we still had a pretty predominant ridging pattern. I mean, we had a little troughing out over here over Southern California, but we had mostly a ridge over most of the West Coast, and that was facilitating warmer, drier conditions. It was still chilly along the coast, and there was some fog as expected. So we have that marine inversion layer, but it was a pretty dry day overall yesterday. Today, very different story as we advance this here. Go into, I mean, this is yesterday evening and then going into the overnight into this morning. And you see these clouds from the trough rapidly making their way through. As expected in May, the troughs are not as strong anymore. It's 556 decameters over here. So I'm going to zoom out, but I think I want to move on to the computer models now. So we're looking at here. This is a projection. This is projecting basically the thickness, which is not exactly the same thing, but it's similar to what we were looking at earlier, which has to do with the pressure heights aloft. And this also showing precipitation, 6-hour precipitation totals, along with sea level pressure. And so what we're going to observe here is, chance of maybe a couple showers for the Bay Area and for the Central Valley throughout the day Saturday. The Sierra has a better chance of seeing rain and snow throughout Saturday because we have more lift, we have more in mountainous areas we have more lift. We have more moisture being squeezed out so we have that precipitation, even though it's not going to really amount to very much. And then we have the drying out pattern. And what's interesting to notice here is Monday morning we have the potential for a offshore wind event, a north to northeast wind event in the Bay Area. And what's driving that would be this system of high pressure up to the north here. I mean, there's a few systems of high pressure. See, there are a couple offshore, and there's one over Washington State. And this is projected for Monday morning. This is a computer model guidance, so take this with a grain of salt. But what this model is projecting is this high pressure to set up in a way that, as we know, as I've talked about before on this channel, so the wind flows from high to low pressure, but there's this thing called the Coriolis effect, which has to do with the rotation of the Earth, which means that in the northern hemisphere, the winds are going to flow in a clockwise pattern around high pressure and counterclockwise around low pressure. So that means that the wind would be doing something like this, because there's like basically a lot of high pressure over here, and there's low pressure over here. There's a low over here. So the wind is going to be doing something like this. This is when you get north to northeast wind in the Bay Area. This is that kind of pattern that you watch for when you're forecasting offshore wind, because this is the setup that can give you offshore wind with high pressure up here over the Pacific Northwest, low pressure over the Great Basin. That can give you offshore wind. Now we're going to take a look at the high resolution model, which is going to give us a better idea of that wind and what it's going to look like. I just want to start out here. See, it's showing dew points now, but I want to show you the wind first, and then I'm going to show you the dew points, because this has to do with what's going to happen with the dew points as the air is going to be drying out. So as I showed, so zoom that out a little. As I showed, oh shoot, okay. This is changing this thing. Alright, here we go. On the other model, the medium range model, you have this high pressure setting up roughly over here with low pressure here. That'll bring sort of a northeast wind flow. And that's pretty much what we're seeing projected here on the, sorry, this is probably wrong time frame. Yeah, there we go. This is what's being projected on the high resolution model. You can see this north wind. This is a north wind here. The greens and yellows and oranges mean stronger winds. So through the mountain gaps here, see, these high resolution models are much better at picking up more localized features such as gaps and areas that the wind gets shadowed. So, but you're seeing this general north flow. I'm actually going to zoom in a little more. I'm going to slowly zoom us in closer to the Bay Area. Because here it's a little easier to see what I'm talking about. Seeing this north wind just racing down the Central Valley and then over the Bay Area mountains. And as this wind goes down these mountain ranges, such as the Sierra Nevada and and you can see it also gets directed by these mountain ranges. She'll turn here when it hits these mountains, and it gets kind of directed in different ways. The mountains create their own wind flow here. It's going to dry out the air significantly. So you go back to the projection for, let's say, 10 p.m. Sunday night. The winds are still just starting out. And you look at what's going on with the dew point, Or let's look at relative humidity. It's gonna be easier for me to explain that way. So here's 10 p.m. Sunday night relative humidity. Bay Area mostly in the 60s and 70s, but then look at what happens when the winds come. Look at how it dries out. Look at 5 a.m. we're looking at 28% relative humidity Santa Rosa, 38% relative humidity for Half Moon Bay all the way to the coast. You're looking at this swath of drier air. Look at how it just blasts down with those winds. And that's a direct consequence of the offshore winds pushing dry air over the mountains, and then at each mountain range that it goes over, it dries out more. So it's going up and down all these mountains and warming and drying, and it gets to the Bay Area, and we got some really dry air. We got 38% relative humidity all the way at the coast here. So very, very impressive. I'm just gonna put a different model just to see, because it goes a little further out. See how that progresses. See into the afternoon, and then it looks like we do get some marine air coming back to the immediate coast, which will bring some more moisture. But yeah, I mean, you can see overnight that dry air just making its way down. And this one actually, yeah, this one doesn't take the dry air as further south. This one keeps a 96% relative humidity in Half Moon Bay, so it's probably doesn't entirely get rid of that marine layer. But you look at the HRRR model, which we were looking at earlier, look how different that is. Where it does bring dry air all the way to Half Moon Bay, 38% relative humidity. See, so you can still have a lot of discrepancy model to model, especially as you're looking a couple days out at this point. So it's something to watch. You know, I will say that the NAM model, from what I've observed, does tend to be more aggressive with the marine air. So it is possible that the HRRR is a little more accurate. Look at the National Blend of models, which kind of does a blend of all models. And yeah, it's kind of in between. It's 72% relative humidity for Half Moon Bay, so kind of humid at the coast still, but not as humid as the NAM, and still pretty dry for areas like Santa Rosa. Relative humidity well down into the 30s here, so it's definitely still seeing this patch of dry air, even on the National Blend of models. So most computer models are in pretty good agreement that there's going to be some intrusion of dry air over the next few days. Anyways, that's all I have for today. I don't want to spend too much more time on this. But thank you for watching. Hope you got something out of this video, and I'll see you next time.